All right, so today we're diving deep into software development security. It's not just a topic on the CCSP exam. It's like the foundation of building trustworthy systems in the real world. All right.
Yeah, definitely.
So, like, picture that you're a developer. It's the night before a big software launch. What's keeping you up?
I'd say it's
What's that one thing?
probably all those hidden vulnerabilities.
Yes.
The bugs in the code that could cause huge problems later on.
Exactly. It's those sneaky little things.
Yeah.
So how do we prevent that?
Well, one thing's for sure. Security can't be an afterthought.
Right.
You can't just patch it up at the end.
Yeah.
It needs to be part of the entire process.
From the beginning.
From the very start. Yeah, the whole software development lifecycle.
So you're saying, like, while the code is being written,
Exactly.
we need to be on the lookout.
Absolutely. You got to catch those vulnerabilities early.
And how do we do that?
One powerful tool is code review.
Okay.
It's like having another set of eyes.
Fresh perspective.
Yeah. Or even better, a whole team of experts.
Right, yeah.
All looking at your code, checking for weaknesses.
I've heard of these formal code reviews. Fagan inspections, are those, like, still relevant?
Yeah, so the full Fagan inspection, the 6-step process, is pretty rigorous.
It seems like a lot.
It is. So most organizations, they kind of adapt it. They fit it to their needs and resources.
Right.
But the core idea, having other developers check your code,
Yeah.
that's essential. It helps you catch those security flaws early on.
Okay, so code review makes sense. But what about actually testing the software itself?
Oh, yeah, that's crucial.
It's got to be more than just making sure it works, right?
Right, there's a lot more to it.
So what else is there?
Well, and this is important for the CCSP exam, too.
Okay.
You got to know the difference between building the right software
Okay.
and building the software, right?
So there's two different things there.
Yeah.
What are they called?
Model validation and verification.
Okay, so is that making sure it meets the goals?
Yes, exactly.
Requirements.
Does it do what it's supposed to do?
Right.
And then verification is does it actually function correctly?
So two sides of the same coin.
Right. And both are super important for managing risk.
Okay.
Think of it like this. You could build the most secure online banking app ever.
Yeah.
But if it doesn't let people deposit checks,
Right.
it's kind of pointless.
It's useless.
Exactly.
Speaking of usefulness, I was reading about this company. They released software without doing proper load testing. And their system, it crashed on launch day.
Oh, that's a classic example
It was a disaster.
of what can happen when you skip load and stress testing.
Yeah, so what exactly is that?
You got to make sure your software can handle real-world traffic,
Okay.
especially during those busy times.
So, like, think Black Friday.
Exactly. Imagine a popular website on Black Friday that can't handle all the shoppers.
Oh, that's a nightmare.
It's a disaster. You lose money. You damage your reputation.
Yeah, customers are going to be angry. So load testing, that's to handle the pressure.
Yep.
What other testing should we be thinking about?
Well, there's user acceptance testing, UAT.
Okay.
This is where you let real users try out the software.
Before it's released.
Yeah, in a controlled environment.
Like a beta test.
Kind of, and you'd be surprised what they find.
Really?
All sorts of usability issues, unexpected problems.
So it's really valuable.
It is. It's all about making sure the software actually meets the needs of the users.
Okay, so we've got the code review, we've got the testing. We're good, right? Ship it.
That's so fast.
What else is there?
What about when you need to make changes later on?
Right.
Add new features. Even small tweaks can have unintended consequences.
So it's not a one and done.
No, that's why regression testing is so important.
Regression testing. Okay, tell me more about that.
So basically, you run your existing tests again.
After you make changes.
Exactly.
Yeah.
To make sure you haven't introduced any new bugs
Oh,
or
yeah.
broken any existing functionality.
I see, yeah.
I read about this company. They made a tiny code change.
Oh, no.
It seemed minor, but it caused a major system outage
Wow.
because they didn't do proper regression testing.
Sounds like a domino effect.
It can be, yeah.
Okay, so we've got the manual code review. We've got all these different types of testing. Are there any tools out there that can automate some of this security stuff?
Oh, yeah, absolutely.
Okay, tell me about those.
There are some really powerful tools that can help automate security testing.
Like robots.
Yeah, think of them as your robot sidekicks,
Okay,
helping you catch those tricky bugs.
I like that.
There's static testing, dynamic testing, and interactive testing.
Okay, and those all do different things.
Yep, each one has its own strengths.
Can you break it down for me?
Sure, so static testing is like an automated code review.
Okay.
The tool scans your code, looking for common errors and security flaws.
Without actually running it.
That's right, it doesn't execute the code.
Interesting.
Now, one type of static testing that's really important, especially for the CCSP exam,
Okay, what is it?
it's called software composition analysis, or SCA.
SCA, got it.
And this is all about finding vulnerabilities in open source components.
That makes sense. So much software uses open source stuff these days.
Exactly. It's everywhere.
Okay, so what about dynamic testing?
So dynamic testing is different. Here, the tool actually runs your code,
Okay.
and it feeds it different inputs to see how it behaves,
Okay.
like under different conditions.
So you're trying to, like, break it
In a way, yeah.
to see what happens.
You're trying to find those weak points.
Okay.
One technique they use in dynamic testing is called synthetic transactions.
Okay.
So basically, you script out actions that simulate real-world user behavior,
Oh, I see.
and then you watch how the software responds.
So it's like creating a fake user.
Yeah, like a virtual user.
Right.
Who interacts with the application.
Those things like adding stuff to a shopping cart?
Exactly. Or trying to apply discount codes.
Yeah.
Or even trying to check out without paying.
So you're trying to, like, trick it?
Yeah, you're looking for those security holes.
Before a real attacker does.
Exactly, that's the key.
Okay, and then what was the third one?
Interactive testing.
Right.
This one's more hands-on.
Okay.
You have a skilled security professional using special tools.
Like a hacker?
Kind of, but they're probing the software for vulnerabilities.
So it's like a combination of dynamic testing.
Yeah, and a human expert poking around
Okay.
to see what they can find.
So it sounds like the best strategy is to use all three of these testing approaches
Exactly. A mix of static, dynamic, and interactive.
to catch everything.
That's the goal, to get the widest coverage.
Okay, and what about white box and black box testing? I've heard those terms before.
Yeah, those are important concepts too.
Can you refresh my memory?
So with white box testing, the testers have access to the source code.
Okay.
They can see everything.
And black box is the opposite.
Right. With black box testing, they don't have access to the source code.
So they're just testing the functionality?
Exactly. They're just seeing what it does, not how it does it.
I see. So each approach has its own benefits.
Yeah, and you often use a combination of both.
Okay, so we've been talking a lot about thinking like developers, trying to build secure software.
Yeah.
But what about thinking like the bad guys?
Oh, that's a great point.
How do we anticipate those attacks?
That's where misuse case testing comes in.
Misuse case testing.
Yeah, it's about putting yourself in the attacker's shoes
I like that.
to find those vulnerabilities before they can be exploited.
Okay, so give me an example.
Let's say you're building a login form
Okay, yeah.
for a web application.
Yeah.
A misuse case test might involve entering a really long username,
Okay.
like 1,000 characters long.
Try to break it
Exactly. Or trying to use special characters that aren't allowed.
to see if it crashes.
Yeah, or if it reveals sensitive information.
Right.
Or if it lets an attacker bypass security.
So it's about intentionally trying to break your own software
In a way.
to find those weaknesses.
Before someone else.
Okay, and what's the best way to do that?
One of the most powerful techniques is called fuzz testing.
Fuzz testing, what is that?
It's basically bombarding the software with random or unexpected inputs.
Like chaos?
Kind of, but controlled chaos.
Okay, so it's not just random.
Right, there's a method to it.
So you're trying to see if it crashes.
Yeah, or if it leaks information, or if it just behaves weirdly.
Okay, so it's a way to stress test the system,
Exactly.
but with unexpected data.
That's right.
Now, isn't that risky?
There's always some risk when you're dealing with software.
Right.
But that's why you do it in a controlled environment.
Okay.
Either on your own systems
Right.
or with explicit permission.
So you're not just randomly attacking things out in the wild.
No, definitely not.
Okay, and are there different types of fuzz testing?
Yeah, there are.
Like what?
There's generation-based fuzzing,
Okay.
where you create inputs from scratch.
You just make stuff up.
Kinda, yeah.
And then what's the other one?
Mutation-based fuzzing, where you take existing inputs and you tweak them in weird ways.
So you're like messing with it
Exactly.
to see what happens.
Yeah,
Okay, so it's like two different approaches to fuzz testing.
right. They both have their own strengths and weaknesses.
And are there tools for this?
Oh, yeah, tons of them.
Really?
Some are open source, some are commercial.
Okay.
They vary in complexity and features.
So there's a whole world of fuzz testing tools out there.
There is. It's a whole field of study in itself.
Wow. It's amazing how much goes into security.
It really is, and it's only getting more important as software gets more complex.
Okay, so we spent a lot of time talking about all these different testing methods, but let's shift gears a bit. Imagine we've written all this awesome, secure code. Where do we keep it?
Well, we use something called code repositories.
Code repository.
Yeah, like Git and GitHub.
Okay, so it's like a storage place for code.
It is, but it's more than just storage.
Okay, what else?
They also provide version control.
What's that?
So it's basically a way to track changes to the code
Okay.
and to collaborate with other developers.
So multiple people can work on the same code.
Exactly, and you can see who made what changes and when.
And you can go back to previous versions.
Exactly, if something goes wrong.
So it's like a time machine for code.
Yeah, kinda.
I like that.
And it helps avoid something called dead code.
Dead code, what's that?
It's code that's still in the system,
Okay.
but no one's actively maintaining it.
Like it's forgotten.
Yeah, it's just sitting there, potentially causing problems.
So code repositories help with that.
Yeah, they make it clear who's responsible for what code.
Okay, that makes sense. But are there any security risks with these repositories?
Oh, definitely.
Okay, like what?
Well, choosing the right repository is important.
Okay.
There's a big difference between public and private repositories.
So public, anyone can see the code,
That's right.
and private, it's limited.
Exactly.
So what's the risk with public repositories?
Well, you wouldn't want to accidentally expose sensitive information,
Like what?
like API keys, passwords, that kind of stuff.
In a public repository.
Yeah, that would be bad.
Yeah, I can imagine.
I read about this developer who accidentally leaked their AWS keys
Oh, no.
in a public repository.
That's a disaster.
It was not a good day for them.
So security is not just about the code itself.
Right.
It's also about how you manage and store it.
Exactly. It's a holistic thing.
Okay, and what about code integrity?
Oh, yeah, that's another important aspect.
How do code repositories help with that?
Well, they play a role in something called code integrity measurement.
Okay, what's that?
It involves using cryptographic hashes.
Cryptographic hashes.
Yeah, it sounds complicated, but it's actually pretty simple.
Break it down for me.
So basically, a hash is like a fingerprint for your code.
A fingerprint.
Yeah, any change to the code will change the hash.
Okay.
So if someone tampers with the code,
You'll know.
exactly, the hash will be different.
That's clever.
Yeah, it's a way to ensure that the code running in production is the exact code that was reviewed and approved.
I like that. It's like a safety check.
Exactly.
Okay, so we've talked about securing the code itself. What about the environment where that code runs?
Ah, good point.
How do we make sure that only approved software can run on our systems?
That's where application control comes in.
Application control. Okay.
It's like having a bouncer at a club.
I like that analogy.
Checking IDs.
Right.
Making sure only the right people get in.
So it restricts which software can run.
Exactly.
Okay, and how does it work?
There are two main approaches: whitelisting and blacklisting.
Okay, good thing about those.
Whitelisting is like a VIP list.
Okay,
Only software that's specifically allowed can run.
so it's very strict.
It is very secure,
Uh.
but it can be a bit harder to manage,
I can imagine.
especially in big organizations with lots of different applications.
Right, yeah.
Now, blacklisting is like a banned list.
Okay.
It blocks known malicious software.
But everything else is allowed,
Right.
so it's a bit more flexible.
Yeah, but also less foolproof.
I see, so there are trade-offs.
There always are.
So whitelisting is more secure,
Generally, yes.
and blacklisting is easier to manage.
Usually, yeah.
Okay, that makes sense. Now, we've talked a lot about security for the code itself, but what about the applications themselves?
Oh, yeah, they need security too.
Always getting those update notifications.
Those are important.
Do applications need patches just like operating systems do?
Absolutely, they need regular security updates.
Okay.
Just like your operating system.
So how do we keep up with all those updates?
That's where automated patch management comes in.
Automated patch management.
Yeah, you need a system that can identify, test, and deploy those security patches.
So it's not something you do manually.
Not usually, no.
Okay. And what about application control? We talked about that earlier.
Right, that plays a role in security monitoring too.
Really? How so?
So you can feed application control logs into your security information and event management system. Yeah, or other centralized log repository.
Okay.
This allows you to detect suspicious activity,
Like what?
like an attacker trying to run unauthorized software,
Okay.
or an insider trying to access restricted stuff.
So it's like a detective tool.
In a way, yeah.
Okay, so logs are important.
Very important.
They help you track down security incidents.
Exactly.
Okay, and finally, what about establishing a baseline? What do you mean by that?
It means taking inventory of all the software that's authorized to run in your environment.
Okay, so you're basically making a list.
Yeah, of all the good software.
You know what to look for.
Right, and it helps you identify any unauthorized software.
That might have slipped through the cracks.
Exactly.
Okay, so it's like taking stock of your software.
Yeah, it's good housekeeping,
I like that.
keeping things organized.
So you can reduce the attack surface.
Exactly. It's all about reducing risk.
Well, we've covered a lot of ground today. From code review to testing to application control. It's amazing how much goes into building secure software.
It's a layered approach.
And it all starts with recognizing that security is an ongoing process.
Absolutely. It's not a one-time thing.
It is not just about checking boxes for an exam like the CCSP.
Right.
It's about building systems that people can trust.
That's the ultimate goal.
With their data, with their
It's
livelihood.
about protecting people.
Okay, before we wrap up, let's recap the key takeaways, especially for those preparing for the CCSP exam.
Okay, so first and foremost, security begins with the code itself.
Okay.
You got to have those rigorous code reviews,
Right.
both manual and automated.
To catch those vulnerabilities early on.
Exactly.
Right. Okay.
What else?
Ugh.
Testing.
We talked about a lot of different types of testing.
We did load testing, UAT, regression testing, static and dynamic analysis, fuzz testing, misuse case testing.
It's a lot.
It is, but it's all important.
Okay, and then what about secure code management?
Right, so using those repositories like Git and GitHub.
To track changes, collaborate, and maintain code integrity.
Exactly.
And finally,
Application control.
whitelisting and blacklisting.
Yep, and make sure you have those robust patch management processes in place.
To keep everything up to date.
Right.
Okay, it's a lot to take in, but it's all connected.
It is. It's all part of the big picture.
Like building a house.
Yeah, a secure house,
With strong foundation
reinforced walls.
and vigilant security guards.
Exactly.
Now, as we conclude our deep dives today, I have one final thought-provoking question for our listener.
Okay, let's hear it.
With all this reliance on open source software these days, how can organizations balance the benefits of code reuse with the risks of vulnerabilities in those open source components?
That's a good question.
Something to think about
Definitely.
as you continue your journey towards CCSP certification.
It's a challenge everyone needs to address.
Okay, well, thanks for joining us today on this deep dive into software development security.
It was my pleasure.
We hope you found it insightful and helpful. Good luck on your CCSP exam.
And in your future endeavors as a cybersecurity professional,
Best of luck.
fuzz testing, that seems kind of, I don't know.
Fuzzy?
Yeah, a little bit.
Well, it kind of is in a way.
What is it exactly?
You're basically throwing a bunch of random or unexpected inputs at the software
Oh, okay.
to see if it breaks, leaks info, or just acts strange.
So you're trying to make it crash?
Yeah, kind of. You're seeing how it handles unexpected stuff.
Okay. And that helps with security.
It does. It helps find those vulnerabilities.
But isn't that kind of risky? Like, what if you actually break something?
There's always a risk with software, but that's why you do fuzz testing in a controlled environment.
Okay, so it's not just random chaos.
No, there's a method to it. You're not just randomly attacking stuff.
Right.
And there are different types of fuzz testing, too.
Like what?
There's generation-based, where you create those inputs from scratch.
And then there's mutation-based, where you take existing inputs and you kind of like tweak them in weird ways.
So you're messing with them to see what happens.
Exactly.
Okay, that makes sense. And are there tools for fuzz testing?
Oh, yeah, tons of them.
Really?
Some are open source, some are commercial. They all have different features and levels of complexity.
So there's a whole world of fuzz testing out there.
There is. It's a whole field of study.
Wow, it's incredible how much goes into security these days.
It really is, and it's only getting more complex.
All right, so we've talked a lot about testing. Let's shift gears a bit. Imagine we've written all this amazing secure code. Where do we keep it?
We use something called code repositories.
Good repositories, okay.
Yeah, like Git and GitHub are popular ones.
So it's like a storage place for code.
It is, but it's also a lot more than that.
Okay, what else does it do?
Well, it provides version control, which is really important.
Version control, what's that?
It's basically a way to track changes to the code over time, and it makes it easier to collaborate with other developers.
So multiple people can work on the same code at the same time.
Exactly, and you can see who made what changes and when.
And you can go back to previous versions if you need to.
Exactly. It's like a time machine for code.
I like that. That's a good way to put it.
And it helps avoid something called dead code.
Dead code, what's that?
It's basically code that's still in the system, but no one's actively maintaining it.
Oh, okay.
It's like forgotten code.
Right.
And that can be a security risk.
So code repositories help with that.
Yeah, they make it clear who's responsible for what code, and they keep everything organized.
Okay, that makes sense. But are there any security risks with these repositories themselves?
Definitely, you have to be careful.
Like what?
Well, choosing the right repository is important.
Okay.
There's a big difference between public and private repositories.
So public means anyone can see the code.
Right.
And private means it's restricted.
Exactly.
So what's the risk with public repositories?
You don't want to accidentally expose sensitive information.
Like API keys, passwords, stuff like that.
Yeah, anything that should be kept secret.
That would be bad.
Yeah, it could be a disaster.
So you have to be really careful.
Absolutely. Security is not just about the code itself.
Right.
It's also about how you manage and store it.
Okay, that makes sense. What about code integrity? How do repositories help with that?
They play a role at something called code integrity measurement.
Okay, what's that?
It involves using these things called cryptographic hashes.
Cryptographic hashes. That sounds complicated.
It's actually pretty simple. Think of a hash as a fingerprint for your code.
A fingerprint.
Yeah, any change to the code, even a small one, will change the hash.
So if someone tries to tamper with the code,
You'll know.
because the hash will be different.
Exactly.
That's a clever way to make sure the code hasn't been messed with.
Yeah, it's a way to ensure that the code running in production is the exact code that was reviewed and approved.
Okay, so we've talked about securing the code itself. But what about the environment where that code runs? How do we make sure that only the right software is allowed to run on our systems?
That's where application control comes in.
Application control, okay.
It's like having a bouncer at a club, checking IDs, making sure only the right people get in.
I like that analogy.
So it restricts what software can run on a system.
Okay, and how does it work?
There are two main approaches: whitelisting and blacklisting.
Okay, what are those?
Whitelisting is like a VIP list.
Only the cool kids get in,
Exactly. Only the software that's specifically allowed can run.
so it's very strict.
It is very secure, but it can be a bit more challenging to manage, especially in large organizations.
Makes sense.
Blacklisting is like having a banned list.
Okay,
You block the known bad stuff, but everything else is allowed.
so it's a bit more flexible.
Yeah, but also less foolproof.
So whitelisting is more secure, but blacklisting is easier to manage.
That's a good way to put it, yeah.
There are trade-offs with each approach. Okay, so we've talked a lot about securing the code itself, but what about the applications? Like, I'm always getting those update notifications. Do applications need security patches just like operating systems?
Oh, absolutely. They need regular security updates, just like your OS.
So how do we keep up with all those updates? It
Mhm.
seems like it could get overwhelming.
That's where automated patch management comes in.
Automated patch management.
Yeah, you need a system in place to identify those patches, test them, and deploy them.
And it needs to be automated.
Yeah, it's really the only way to manage it effectively, especially at scale.
All right, and what about application control? We talked about that earlier.
Right, well, that also plays a role in security monitoring.
Really? How so?
You can feed application control logs into your SIEM or other centralized log repository.
Okay.
And that helps you detect suspicious activity, like someone trying to run unauthorized software.
So it's like a detective tool.
Yeah, it helps you track down those security incidents.
Okay, that's cool. And what about establishing a baseline? What does that mean?
It basically means taking inventory of all the software that's authorized to run in your environment.
Okay, so you're making a list of the good software, so
Exactly.
you know what to look for.
Right. If something's running that's not on that list, you know it's suspicious.
So it's like taking stock of your software, making sure everything's accounted for.
That's a good way to put it. It's like good housekeeping for your software environment.
I like that.
It helps you keep things organized and secure.
So it helps you reduce the attack surface, right?
Exactly. It's all about reducing risk.
All right, well, I think we've covered just about everything today, from reviewing the code and all those different types of testing to fuzzing and application control. It's really amazing how much goes into building secure software.
Yeah, it's a multi-layered approach for sure.
And it all starts with that mindset.
Yeah,
Security has to be a priority from the beginning.
absolutely. It can't be an afterthought.
And it's not just about passing an exam like the CCSP.
Right. It's about building systems that people can actually trust.
Exactly, with their data, their money, everything.
It's about building trust.
Okay, so before we wrap up, let's just quickly recap the key takeaways, especially for our listeners who are studying for the CCSP.
Okay, so first and foremost, security starts with the code.
Right.
Gotta have those code reviews, both manual and
To
automated.
catch those vulnerabilities early.
Exactly.
Then testing, testing, testing.
So important.
We talked about a bunch of different types of testing.
Load testing, UAT, regression testing, static and dynamic analysis, fuzz testing, misuse case testing.
The whole shebang.
It's a lot.
It is, but it's all crucial for building secure software.
Okay, and then what about managing the code securely?
Right, using those code repositories.
Git and GitHub.
Yeah, to track changes, collaborate effectively, maintain that code integrity.
Okay, and finally,
Application control, whitelisting, blacklisting, and don't forget about patch management.
keep those applications up to date.
Absolutely.
All right, so there's a lot to take in, but it's all connected, right? It is. It's all part of the bigger picture of building secure systems.
It's like building a house
Yeah, a really secure house.
with a strong foundation.
Reinforced wall.
Alarms, cameras, the whole 9 yards.
You got it.
Okay, well, as we wrap up today's deep dive, I have one final question for our listeners to ponder.
Okay, hit me.
With so much reliance on open source software these days, how do we balance the benefits of reusing that code with the potential risks of vulnerabilities that might be hiding in those open source components?
That's a good one.
It's something to think about.
Definitely.
It's a challenge that every organization is facing. So consider that as you continue on your journey to becoming a CCSP.
Food for thought.
All right, well, thanks for joining us on this deep dive into software development security.
It was great to be here.
We hope you found it helpful and insightful. Good luck in your CCSP exam, and good luck in all your future endeavors as a cybersecurity professional.
Best of luck, everyone.